Amelia.
And I'm Madison.
And today we're going to be talking about benzene derivatives.
So, the structure for benzene, which you probably know or should know for this, can be drawn as but due to the resonance in the double bonds, it can also be drawn as,
which is often a simplified version and easier to draw than the tedious double bonds.
So now we're going to get into naming of benzene derivatives when you have single substituents. So when you just have one thing attached to the ring, you name it according to its substituent. So for example, if you have a bromine attached to a benzene ring, like so, you would name it bromobenzene.
Now, say you have a chlorine attached to the benzene ring, and it doesn't matter at which point since it's only a single substituent, you would call it chlorobenzene.
Other versions can be if you're going to attach a methyl group, you can call it methylbenzene. However, there are common names too. So when a methyl is attached, the common name for it is toluene.
Another common one that we have a common name for, which you could call hydroxybenzene, is known as phenol, which is much shorter and simpler to say. Some other examples of benzene derivatives that have common names are benzoic acid,
Acetophenone,
and we also have benzene sulfonic acid,
and aniline or aniline.
So, to save yourself some time when naming benzene derivatives, these 5, benzoic acid, sulfonic acid, aniline, acetophenone, and toluene are, and phenol, that's the 6th one, are good ones to use. Now, we are going to talk about naming benzenes with multiple substituents. So first, we can talk about dimethyl substituents known as xylenes. This is an easy example to start out with. So, when naming benzenes with multiple substituents, you name them by which carbon they're at. So, this can be called 1, 2, dimethyl benzene.
Another example would be if you had one carbon in between the two substituents, and you'd call this 1,3-dimethyl benzene.
And the last possible orientation for two substituents on a benzene ring is having 2 carbons between the two substituents. And here we would call this 1,4-dimethyl benzene. Now, another way to name this structure, as there's no carbons in between the two substituents, is ortho-dimethyl benzene. And the shorthand for this, instead of writing out ortho, you can just write O.
Now the same naming can be done for if there's one carbon in between. So if you have two substituents with one carbon in between, it's called meta can also be shortened to M.
And the final orientation with 2 carbons in between the 2 substituents is para-dimethylbenzene, which can be shortened to p-dimethylbenzene. And this will come up later in our lecture.
Okay. So some examples of some structures. That you can see the naming we just talked about with would be so this structure here has a methyl group, 1 carbon in between, and a hydroxy group. So we could name this 1-hydroxy 3-methyl benzene. However, using the common names that we brought up before, you could also name it 3-methyl phenol, or using the system we just talked about with the letter orientations, you can use M for meta-methyl phenol, since there's 1 carbon in between the substituents.
And look how much nicer this looks than this one. So, another example we have here, the long way you could write it out is 1-chloro 3-methylbenzene. However, sorry, my bad, we all make mistakes. However, if you want to use the common name that we just talked about, for if there's a methyl substituent, we can call this 1-chloro toluene. And finally, with the letter naming that we just talked about, this could also be called p-chlorotoluene, where the P stands for para, as there's 2 carbons in between the 2 substituents. So typically, if you have an electron withdrawing group on a benzene ring, the second substituent will go to the meta position. So this is deactivating and meta-directing.
Now, if you have an electron donating group, such as a hydroxy group, it'll go to either the ortho or the para placement. So it could go here or it could go here.
Now, there's certain exceptions, such as halogens, where they are deactivating, like NO2, but they're also ortho-para-directing, such as this. Now, we have a summarized list that we will pull up for your convenience.
So here we have the summarized list of ortho, para, and meta directors, and we have them split into categories based on how activating or deactivating they are. So under ortho, para directors, we have strongly activating groups. Some examples are an OH group or an O- group. Then there's moderately activating group. An example from that would be an OR group. A weakly activating groups, an example would be a phenyl ring or just an R group. And then weakly deactivating groups is the halogens, so fluorine, chlorine, bromine. Meta directors, we have moderately deactivating groups, so an example is a cyanide substituent. And strongly deactivating groups, we have NO2 or CF3. So now we're going to do some examples using this chart and everything you've just learned about naming.
So, first, we'll start out with a simple example. Say we have a benzene ring with a hydroxy group, so a phenol, which we should already know from our common names. Now, say we have some reaction that's going to put on a bromine. We can refer to our chart here and see if this is, find the OH and see if it's ortho, para, or meta-directing. And here we can see that the OH group is ortho-para-directing. position, and excuse my drawing, I'm going to have to draw a slightly different orientation. So at the ortho position and the para position. Now, as we don't have any other substituents on here, both of these will be produced. However, sometimes, due to sterics, one of the positions will be favored over the other.
So another example is if we have a benzene derivative with cyanide already attached, and we undergo the same reaction, which is going to put a bromine onto the ring. So then we go over to the chart again. You can see that it's not in the ortho-para directors. So we move on, and it's over in the meta-directors category. So that means that when the bromine gets added, it gets added to one carbon in between, and you only get one product in this case because obviously there's no other orientation that you're going to get, because if you put it there and flip it, it's the same thing.
Now, here we have another slightly more complicated example where you have to consider multiple substituents and if they're ortho, para, or meta-directing. So, if we look at our first one here, we see that it's meta-directing, which means it could go to this position or this position. However, we already have something here, so obviously it will favor this position. Likewise with this group. Now, chlorine, as you look over on our board, you can see that it is in the ortho-para directors, right here. Now, typically, it could go to the ortho position or the para position. However, if you look at both of the ortho positions to chlorine, they're already taken. So it's going to have to go down to the para position, which will give us, let's throw in a bromine once again, will give us this product. Now, say these did not all favor the same position, you would go based on which substituent was the most activated. And come on in here with me, Madison. That is our quick lesson on benzene derivatives. We hope you enjoyed and hope you learned something today. Maybe you know just a little bit more about how to name these guys.
Good luck on your next organic test.